Hello, I'm Marwa, and my research name is Studying the Fracture Surface of Brass CuZn37 and Aluminum1100 and their relationship with formability in single point incremental forming. Objectives: the research addresses the gap in understanding the role of microstructural void characteristic in formability and fracture behavior during single point incremental forming. Prior studies lack detailed analysis correlating void parameters such as void volume fraction and size distribution with formability metric like fracture depth and maximum wall angle. This study investigates the forming of brass and aluminum, analyzing void characteristic in fracture zone using scanning electron microscopy and imaging. It highlights the impact of input parameter on formability and microstructural change, classifying void into five size category. The findings offer novel insight into microstructural effect on the incremental sheet forming. Two types of ductile material with a dimension of 115 per 115 mm have been formed in a hyperbolic truncated pyramid with varying wall angle. A tensile test of standard specimen was performed to obtain the mechanical properties of this material. This table shows the input parameter with their level that used in this work to conduct the single point incremental forming, and the method that followed to conduct the experiment in this work is based on dividing the experiment of each material in two groups. Each group was divided into three experiments to test the three levels of a specific input parameter that affect the formability. This table shows the results of the fracture depth and maximum wall angle, and this figure shows the resulting specimen of the experimental work. Results of the fractography analysis. The fracture zone of 10 selected specimens were cut from the whole specimen using wire-cut EDM. The fracture surface then examined using SEM. These two figures show the SEM photograph of the fracture surface of brass and aluminum. These figures show the image analysis photo of the SEM for the brass and aluminum fracture surface to find the relationship between formability and their microstructure. The analysis results of ImageJ software for the percentage of void volume fraction and average void size of ductile material have been shown in this table. From these results is found that the relationship between formability and their percentage of void volume fraction and average void size is direct. And this is the results of the classification of the form size into very small, small, medium, large, and very large. Conclusion: in the brass, oblate void were mainly formed into the specimen with moderate formability, spherical void in the relatively high formability specimen, and a combination of oblate and prolate void was observed in the specimen with lower formability, while in aluminium, parabolic void forming in high formability specimen and prolate void in specimen with moderate to high formability. A direct relationship was found between formability and void characteristic. In the brass, the void volume fraction was maximized when all input parameters were set to medium level, while in aluminum, optimum conditions were achieved with low feed rate, high tool rotation speed and sheet thickness, and medium tool diameter and step size. Thank you.